Hello students, today's first question is, in a school that had a total of 600 students enrolled in the junior and senior classes, the students contributed to a certain fund. If all of the juniors but only half of the seniors contributed, was the total amount contributed more than $740, right? So what we have been given is, in a school the total of 600 students enrolled in junior and seniors is equal to 600, and moreover we also know that if all of the juniors but only half of the seniors contributed, so we don't know the number, that how many are the juniors, so all the juniors but only half of the seniors contributed. Now their contribution, let us suppose if their contribution is not same, so let J be the number of juniors and S be the number of seniors. So J's contribution be C1 plus 1 by 2 S into C2. It can be same, C1 and C2 can be same also or different also. We don't have such information right now, but we have to calculate just that the number of juniors contributed and half of the seniors contributed, and this amount should be greater than $740 or not, right? Now with this we will move to the first statement. First statement says that each junior contributed $1 and each senior who contributed gave $3, right? So here we don't know the number of juniors and number of seniors, so we can't be concrete that let us suppose number of juniors be 450, right? And let us suppose this is juniors and seniors be 150, right? In this case 450 into 1 plus, we know that half of the seniors contributed, so 75 into 3, so this will be 450 plus this will be 225. Adding this will be get 5, 7, and so this amount is less than $740. So it says no, amount is not greater than $740. But if we assume that J is equal to 200, right, and number of seniors be, that case will be 400, right? And half of the seniors contributed, so 200 into 1 plus 1 by 2 of 400 is 200 into 3. So this amount is 600 plus 200, 800. So in this case, this amount is greater than $740. So we'll say yes. So statement A is not sufficient to answer this question, right? Now moving to statement 2. Statement 2 says there were more juniors than seniors enrolled in the school. So we have supposedly assumed this. So this example can be taken where we will say that 675 is less than, and for more juniors we can take another example, but since that is not able to solve our problem, so B is also not able to solve this question. Now taking both the statements together, first statement says that each junior contributed $1 and each senior contributed $3, right? So and there were more juniors than seniors, so there is one condition that if they are equal, then junior is equal to 300 and then seniors is equal to 300, but juniors has to be greater than seniors, so juniors number of juniors has to be greater than 300 and seniors has to be less than 300, right, in order to make the total equal to 600, right? So if we take 299, 301 as juniors and each contributed using statement 1 and 1 plus, let us suppose this to be 302, so this will be 298, so half of this will be 149, right? So 149 into 3. So this amount comes out to be 302 plus 447 equal to 302 plus 447, 749, right? But there is one thing which we are missing, that each senior who contributed. So we don't know that the half of the seniors really contributed to this, right? So combinedly statements 1 and 2 are not able to solve this question, that whether the total contribution is greater than or less than or equal to 740. So statement E is the right option, that none of the statements are sufficient to answer this question. How much did credit card fraud cost United States banks in year X to the nearest $10 million, right? So this is the question, that the credit card fraud cost in year X to the nearest $10 million. So this is the question. Now statement 1 says that in year X, counterfeit cards and telephone and mail order fraud accounted for 39% of the total amount that card fraud cost the bank. So this gives us that counterfeit cards plus telephone fraud and mail order fraud accounted for 39% of the total credit card fraud. So this doesn't give us the information about how much is the total credit card fraud. So statement A is not sufficient, which makes statement D also not sufficient. Now we will look for statement 2. In year X, stolen cards accounted for 158.4 million or 16% of the total amount that credit card fraud cost the bank. So that means that 16% of credit card fraud, right, is equal to 158.4 million. So from here we can calculate credit card fraud, which will be equal to 158.4 divided by 0.16. So this can be easily calculated from here. So we can say that the statement B is sufficient to answer this question, right? So for this, statement 2 will be we need not to find the value. We just can find that statement B is sufficient to find the answer. Is the positive integer n odd? So this is the question, that n is a positive integer has been given to us. We need to find that is n odd, right? We have only been given that n is a positive integer. Now statement first. Statement first says that n square plus n plus 1 whole square plus n plus 2 whole square is even. Now two cases arise. First we need to know that what is n plus 1 and n plus 2. So n basically n plus 1 and n plus 2 are three consecutive integers, right? Now two cases arise. If n is even, then n plus 1 will be odd and n plus 2 will be again even, right? Or there can be a case where n is odd, then n plus 1 will be even and n plus 2 will be again odd, right? Now since we have been given that this n square plus n plus 1 whole square plus n plus 2 whole square is even, so we'll try to find out in which case it comes out to be even. Now if n is even, then n square is even, right? Now n plus 1 whole square being n plus 1 being odd, and we know that odd into odd is equal to odd, so n plus 1 whole square will be odd. Now n plus 2 is even, so n plus 2 whole square will again be even, right? Now even plus even is even, and even plus odd is odd, right? So even plus even will give us an even number, and even plus odd will give us an odd number. So finally it is an odd number, but here it has been given that this is an even number. So this possibility is the only left possibility, that n has to be odd. So that means A satisfies our question, that is n odd. Yes, n is odd. Why? You can calculate that odd multiplied by odd is n square will be odd, n plus 1 will be even into even, n plus 1 whole square, and n plus 2 whole square, that is odd into odd will be odd. Now odd plus odd is even, and even plus even is even, which has been given in the statement that this is even. So that can only be possible if n is odd. So statement A is sufficient. Now moving to statement 2. Statement 2 says that n square minus n plus 1 whole square minus n plus 2 whole square is even. Now in the first case we have studied it with the help of n plus 1. Now we assume some numbers. Now let us suppose that n is equal to 3, then n plus 1 will be 4 and n plus 2 will be 5, right? Now 3 square is 9 minus n plus 1 whole square is 16 minus n plus 2 5 square is 25. So this is basically 31, 41. So this will be equal to minus 30, right? So this is even, which satisfies this, and n is odd, right? So from this also, now let us suppose we have n is equal to 2, then n plus 1 will be equal to n plus 1 3 and n plus 2 4. Now 2 square, which is 4 minus 9 minus 16. So this is basically 4 minus 25. So this is minus 21, which is odd. Now if n is even, then this whole will become odd. So that means n has to be odd in order to have this even. So this is the condition which is satisfying. So n has to be odd. So this also satisfies and gives us the answer that n is odd. So statement B is also alone sufficient to answer this question. So right option for this will be option number D, that each statement alone is sufficient to answer the question. In the xy plane, circle C has center 1, 0 and radius 2. Right, so this is a coordinate system, and circle has at center 1, 0, right, and radius equal to 2. So radius is 2, so that means it will cross through 3, 0, and here 1 over here and minus 1, 0. So we will draw a circle. So this is a circle with center at 1, 0. Now, if line K is parallel to the y-axis, so this is the y-axis, y, and this is x-axis. We have been given that the line is, let us suppose this is that line, is parallel to y-axis. Is line K tangent to circle C? So this is circle C. It says that is this tangent to circle C. First statement says line K passes through the point minus 1, 0. So this is parallel and this passes through. In first statement it is given that it passes through minus 1, 0. So it will pass like this. Two conditions have to be fulfilled. One is from the main statement that it is parallel to y-axis, and second is it passes through minus 1, 0. So if it is passing through minus 1, 0, So this will touch the circle at this point minus 1 comma 0. So we will say that yes, it is tangent to circle C. So statement 1 is sufficient to answer this question. So we'll mark option A. Right? Now we'll look for the statement 2. If statement 2 is also correct, then we'll mark option D. Otherwise, option A will be the right answer. Now, second statement says that the line K passes through the point minus 1 comma minus 1. Now there are two conditions. One from the main, that K is parallel to y-axis and it passes through point minus 1 comma 1 minus 1. So that point will lie on over here. Right? Now since this point K is passing through minus 1 comma 1 and it is parallel to, so it will pass through minus 1 comma 0 also. Right? So basically it is simply saying that this is a line which is having x equal to minus 1 as its equation. So this also is sufficient to answer our question that this is tangent to the circle, because if it is passing through this point and it is parallel to y-axis, then it will definitely pass through minus 1 comma 0. So statement B is also sufficient. So we will mark option D, that both the statements alone are sufficient to answer this question. A certain company consists of 3 divisions, A, B and C. Of the employees in the 3 divisions, the employee in division C have the greatest average arithmetic mean annual salary. Is the average annual salary of the employees in the 3 divisions combined less than 55,000? So we have been given a company which has 3 divisions, 1, 2, 3, A, B and C, and out of this the average mean of company C is greatest. Right? Now, is the average annual salary of the employees in 3 divisions combined less than 55,000? So this is the question which has been asked to us. Now statement 1 says that the average annual salary of the employees in the division A and B combined is 45,000. Right? Now what does that mean? So this means that, let us suppose over here that NA, NB and NC are the number of employees in the 3 divisions. Now A is the combined salary and divided by number of employees of in division A plus summation of B, total salary of each employees, divided by number of employees of section B. So this has been given combined to be 45,000. Right? Now C divided by NC, we have been given that it is greater than, so this is the sum of 2 averages. Right? So C by NC has to be greater than this. Right? But we are still not able to calculate the total, right? That whether it is greater than or less than 55,000 or less than 55,000, right? So statement A is not able to answer our question. So that means statement D is also not an option over here. Now statement 2 says that the average annual salary of the employees in division C is 55,000. So the average annual salary, so that means number of summation of C, that means total number of salary and number of employees in section C is equal to 55,000. Right? Now we also note from the main statement that C is having the greatest average mean salary. Right? So that means sigma A upon NA will have to be less than 55,000. Right? And sigma B divided by NB has to be less than 55,000. From this I can calculate that sigma A is less than 55,000 multiplied by number of employees in section A, and solution B is less than 55,000 multiplied by number of employees in section B. Right? And sigma C is equal to 55,000 multiplied by number of employees in section C. Now if we combine this, so this is less than this. Now let us assume this to be equal. So total average will be equal to 55,000 NA plus 55,000 NB. Remember, we have assumed this to be equal, right? Plus 55,000 number of employees in section C divided by total number of employees, that will be NA plus NB plus NC, right? So this will be equal to, if I take 55,000 common, so this will be NA plus NB plus NC divided by NA plus NB plus NC. So this will get cancelled and we will be left with 55,000. Now this is when I assume this to be equal. So basically this is less than this number has to be less than. So this means overall this has to be less than 55,000. So this means our question has been solved, that option B is the right answer. Statement 2 alone is able to sufficient, that because we have assumed this to be equal, but this is practically less than 55,000, this number. So this will make this total less than this, right? So the combined salary of the employees in the 3 divisions is less than 55,000. So statement B is the right answer. For all x, the expression x star is defined to be ax plus a, where a is a constant. What is the value of 2 star? So if x star is represented as ax plus a, then 2 star will be represented as twice a plus a, or this is thrice of a, right? So basically we need to find the value of a. So whichever statement gives us the value of a, that is sufficient to answer this question. So first statement tells us that 3 star is equal to 2. So what does that basically mean? This means that a dot 3 plus a is equal to 2, or this implies 4a is equal to 2. This implies a is equal to 2 by 4 or 1 by 2. So this is sufficient to answer the question. So we can say that statement a is okay to solve this question. Now if statement 2 is also sufficient, then we'll mark option D, otherwise option A. Statement 2 says that 5 star is equal to 3. So this means basically a dot 5 plus a. So this is 5a plus a, 6a, which is equal to 3. So this implies a is equal to 3 by 6 or 1 by 2. So that means this is also providing us individually the value of a. So this is also sufficient. So that means both statements A and B are sufficient. So for this we will mark option D, that both statements are individually sufficient to answer this question. Is k plus m less than 0? So we have been asked simply, is k plus m less than 0 or it is negative? Nothing else has been provided in the main statement. So we have to find this. Is k plus m less than 0 or it is negative? Now we'll go directly to the statement 1. So this says that k is less than 0. So what do you think that from the given information that k is less than 0, can we answer this question k plus m less than 0? So we'll see two cases. Let us suppose k is equal to minus 2, right? And m is equal to minus 1. So adding this will get minus 3. So this means that k plus m is less than 0. So we'll say yes, right? But if k is equal to minus 2, and let us suppose m is equal to 3. So in this case, now k plus m will become greater than 0. So we'll say no. So this is a may or may not be situation. So in this case, we will say that a is not sufficient to answer this question, right? Now, second case, we have been given that k multiplied by m is greater than 0. So that means this is a positive. K and m product is positive. Now this can happen in two ways. Now first is if I take both k negative and m negative. So we know that minus multiplied by minus. So minus multiplied by minus will give us a positive value. So this can also be the case. And in this case, k plus m will be less than 0, right? So it will say yes. Now in other case, if I take k to be positive and m to be positive, in that case also km has to be greater than 0. So in that case, k plus m will be greater than 0. So it will say no. So again, we are having may or may not be condition. So option B is also not individually sufficient to answer this question. Now we will go for the combining statement 1 and statement 2. Now from this, we can deduce that first statement says that k is negative. First statement says that k is less than 0, so k is negative, right? And second statement says that km is greater than 0 or it is positive. So this can happen only in a case where we have said that m is, now k is negative, that is given. So in order to have this product to be positive, I will say that m has to be negative. Otherwise, if m is positive, this condition won't be satisfied. So that means minus into minus will give us positive value, right? So from this, I can say that if both are negative, this is given and m has to be negative in order to have this product k into m greater than 0, right? So I can say that k plus m has to be less than 0 because k is minus negative and m is also negative in order to have this product positive. So this will give us a negative result which is less than 0. So yes, we can say that statement C, that both the statements combined can give are sufficient to answer this question. So option C is the right answer. The symbol triangle represents which one of the following operations? Addition, subtraction or multiplication. So we have been simply given that this, what does this represent? Is it addition or subtraction or multiplication? So this is the question. Now statement 1 says that A triangle B triangle C is not equal to A triangle C triangle B, right? Now we will solve this by taking some examples for A. Let us suppose A to be 2, B to be 3 and C to be 5. Now options available for triangle to be addition, subtraction or multiplication. So first of all we use addition. So that means 2 plus bracket 3 plus 5 is not equal to 2 plus bracket 5 plus 3. So this is 2 plus 8 not equal to 2 plus 8. So 10 is not equal to 10. So that means this, we have been given this condition should be satisfied, but this is not satisfied. Actually 10 is equal to 10. So addition is not a case, right? Now we will go with subtraction. So 2 minus 3 minus 5. Right? Here we won't be putting equal to or not equal to. So here it is equal to 2 minus 5 minus 3. So this is basically 2 minus minus of 2, and this is 2 minus 2. So this will be 2 plus 2, 4, and this is 0. So this is not equal to, and this is being satisfying the what has been given to us. So this triangle should represent subtraction. Now we will check it for multiplication. If it is this inequality holds, then there are two options for us. Then statement A will not hold true. Now 2 multiplied by 3 multiplied by 5, and here it has been 2 multiplied by 5 multiplied by 3. So this is 5 3 15 into 2 30, and this is 5 into 3 50 again 30. So this is equal to, so that means multiplication is also, so we are getting a single answer, that is subtraction. Triangle represents subtraction. So we can say that statement A is sufficient to answer our question. Right? Now moving to statement 2. So statement 2 says that A triangle B triangle C is not equal to A triangle B triangle C. Right? Now let us suppose again that we have numbers A equal to 2, B equal to 3, and C equal to 5. You can take some other example also. Now we will first do the same case for addition. So this says that 2 plus 3 plus 5, leaving the equality or inequality sign. So here it is 2 plus 3 and plus 5. So this is 8 plus 2, 10, and here also 5 plus 5, 10. So this is equal to, so that means addition is not the case. Right? So sorry, I will not bracket it. So A is not addition. Now we'll check it for subtraction. So 2 minus 3 minus 5, and here it is 2 minus 3 minus 5. So this is 2 minus minus of 2, right? And here it is minus 1 minus 5. So this is 2, 4, and this is minus x. So this is not equal. So we can say that subtraction, this inequality holds true for subtraction, right? Now we will check it for multiplication. So for multiplication, 2 into 3 into 5, and here it is 2 into 3 into 5. So this is 30, and this is 30. So this holds true. So multiplication is also not this symbol. So here also we are getting single answer, and that is subtraction. So we can say option B is also alone sufficient to answer that this triangle represents only subtraction. Both these statements are individually answering this question. So we'll mark the option D, that each statement is individually sufficient to answer this question. What is the value of 2 raised to power x plus 2 raised to power minus x? So we have been simply asked what is the value of this. Right? Now moving to statement 1. Statement 1 says that x is greater than 0. Now we will check for two values, but we know that if let us suppose x is equal to 1. Right? So in that case 2 raised to power 1 plus 2 raised to power minus 1. So this becomes 2 plus 1 by 2. So this will be 2, 4 plus 1, and this will be 5 by 2. So this is the value. Now if I change the value of x, let us suppose x is 2. So this will become 2 raised to power 2 plus 2 raised to power minus 2. So this will be 4 plus 1 by 4. So this will be 4 plus 16 plus 1. So this will be 17 by 4. So we are getting two values, and if we change the value of x, we will get another different value. So statement 1 A is not able to answer our question. Now statement 2. Statement 2 says 4 raised to power x plus 4 raised to power minus x equal to 23. Now we can relate this with 2 raised to power x plus 2 raised to power minus x. Now we need to find the value of 2 raised to power x plus 2 raised to power minus x. Right? Now if I scaring it, I will get 2 raised to power 2x plus 2 raised to power minus 2x plus 2 dot 2x multiplied by 2 raised to power minus x. Fine. So this will be basically equal to, this is 2 raised to power 2, so 4 raised to power x plus 4 raised to power minus x, plus this will get cancelled. So this will be having plus 2. Right? Now 4 raised to power x plus 4 raised to power minus x has been given to us as 23. So shifting this to this side, I will get 23 plus 2 equal to 2 raised to power x plus 2 raised to power minus x whole raised to power 2. Right? So this implies 2 raised to power x plus 2 raised to power minus x equal to under root of 25, which is equal to 5. So we have finally found the value of 2 raised to power x plus 2 raised to power minus x, which is equal to 5. So this means that statement B is alone sufficient to answer this question. So right option for this will be statement 2, statement B. What is the ratio of C to D? So we have to simply find C by D. Right? Now statement 1. Statement 1 says that the ratio of 3C to 3D is equal to 3 by 4. So if I cancel 3, I would be getting C by D equal to 3 by 4. So our answer has been individually solved by the statement A. So I can say that statement A is sufficient to answer this question. Now let us see what statement 2 says. Statement 2 says that the ratio of C plus 3 divided by D plus 3 is equal to 4 by 5. Now is this able to solve our question? Now let us see. By cross multiplication, I will get 5C plus 15 equal to 4D plus 12. So I can further solve it. If I suppose some values for C and D, I will get different ratios, right? So we can say that statement B is not able to find us the value of C by D, right? Let us suppose we have C equal to 1 and D equal to, for making it 4:5. So let us suppose C is 1 and D equal to 2. So this will become 3 plus 1, 4, and 3 plus 2, 5. So this is the ratio which has been given to us. So this actually comes, so for that C by D will be equal to 1 by 2. Now we have to find another value for which the ratio comes out to be 4 and 5. So let us suppose if C is equal to 5 and D is equal to 7, then 5 plus 3, 8 divided by 7 plus 3, 10. So this is basically again 4 by 5. So ratio is again same, but the value of C upon D is here is 5 by 7. So this means we are getting two values for C by D, or we can have some other values just by keeping in mind that it has to be C plus 3 upon D plus 3 should be equal to 4 by 5. So we are getting multiple values, so B is not an option. So right option for this will be statement A alone is sufficient to answer this question. A candle company determines that for a certain specialty candle, the supply function is P is equal to M1x plus B1 and the demand function is P is equal to M2x plus B2, where P is the price of the candle, X is the number of candles supplied or demanded, and M1, M2, B1 and B2 are constant. At what value of X do the graphs of supply function and demand function intersect? So we have been given that these are the supply and demand functions. So in order to find the value of X where these meet, so we have to put supply function, that is M1x plus B1 equal to M2x plus B2, right? Taking this common, so I will be getting M1 minus M2 into X equal to B2 minus B1, right? Now moving to statement 1. So statement 1 says that M1 is equal to minus of M2 is equal to 0.005, right? So from this I can deduce that M1 minus M2 is equal to, will be equal to, so this will be 5 by 1000, right? So minus of M2, so this is minus of M2 is equal to this, so M2 will be equal to minus of this, so this minus will be, make it positive, so this will be equal to this, so 1000 as LCM, so I will be having 10. So this is basically 0.01, 1 by 100. So I can put this value over here, 0.01 multiplied by X equal to B2 by B1. Now the value of X will vary as the value of B2 minus B1 and B2 will vary, and we are not given the value of B1 and B2, so I will say that statement A is not sufficient to answer this question, right? Now moving to statement 2. Statement 2 says that B2 minus B1 is equal to 6. Now if M1 minus M2 is multiplied by X is equal to 6, then I need to have the values of M1 and M2, so that means B statement is also not sufficient. And now we'll check if both the statements are sufficient to answer this question. Now taking this both, I will get M1 minus M2 is 0.01, so I will write over here from statement 1 that this is equal to, now we are checking for statement 1 plus statement 2. So M1 minus M2 is 0.01 multiplied by X, so B2 minus B1 is given to be 6, so from this X comes out to be 6 upon 0.01, or this will be equal to 600. So now we are able to calculate the value of X, which is equal to 600. So we can say that statement C, that means statement A and B combined, can answer this question. So right option for this will be statement C. A certain ski shop sold 125 pairs of skis and 100 pairs of ski boots, right, for a total of $75,000. What was the average arithmetic mean selling price of a pair of ski boots? So now let us suppose that summation skis is the total revenue generated from by selling 125 pair of skis, and summation SB represents ski boots, right? Now we have been given that summation of skis, summation of S plus summation of boots, so let us suppose this be boots, so that is equal to $75,000, right? Now what was the average arithmetic mean selling price of a pair of ski boots? So we need to find sigma B upon how many boots are there, so there will be 100 pairs, right? So we need to find this. Now, statement 1. Statement 1 says the average selling price of a pair of skis was $300. So now this means that how many skis are there? 125, so 300 multiplied by 125 will give us sigma skis, right? So if you want, we can calculate it also. So 300 multiplied by 125, so this gives us 337,500. So this is the total cost of sigma C's S. Fine. So sigma B can be calculated from where? By 75,000 minus 37,500. Right? So this comes out to be 37,500. Now we need to find the average selling price of a pair of ski boots. So that can be calculated. Now sigma B has been calculated, dividing it by 1000 we can calculate. So statement A is sufficient to answer this question. And if you want the price, so that will be 37,500 divided by 100, which is equal to 375 for a pair of ski boots. So statement A is sufficient. Now moving to statement 2. This is also sufficient, and option D will be the right option, or otherwise option A. Now this says that the price of the selling price of a pair of ski boots varied between $150 to $900. So we can say that price of boot varies between $900 to and greater than $150. Right? Now from this we can't calculate the average price of a, let us suppose the price of this to be fixed as 200, right? So then the total price we can calculate for this, and number of skis also can calculate it, but we are not able to find the exact price. So option B is not sufficient to answer this. So right option for this question is statement A alone is sufficient to answer this question. Is the length of rectangular field F greater than length of rectangular field G? So we have been given two rectangular fields. One is rectangular field F and one is rectangular field G, right? So we need to find, let us suppose the length of this is L and this is B, and this is L1 and this is B1. So we need to find that whether L is greater than L1, right? Now moving to statement 1. Statement 1 says us that the area of F is greater than area of G, right? Now this means that L into B is greater than L1 into B1. Now we will try to solve it with some possibilities. Now let us suppose that L is equal to, we have to make this area greater. L is equal to 5 and B is equal to 4, right? Now here let us suppose L is L1 and B1. So L1 is equal to 10 and B1 is equal to 1, right? So 20 is greater than 10, and here we can deduce that L is less than L1, right? Now we will take another case in which we will try to make L greater than L1. So let us suppose again L is equal to 5, B is equal to 4, and L1 is equal to 4 and B1 equal to 4, right? So LB becomes 20 and this becomes 60. So making the area greater than this. Now in this case L is greater than L1. So this arises a condition may or may not be. So option A is not sufficient to answer this question. Now statement 2. Statement 2 says that the width of F is less than width of G. So that means statement B gives us that width of F. So B is less than B1. So in this case we have to make another case in which we will say that, let us suppose L is equal to 5 and B is equal to 6. So we have to keep that B is less than B1. So B is less than B1. So let us suppose this is A, right? So this is 30. So let us suppose L is equal to 4, L1 and B1. So this makes LB 30 and L2, sorry, if I keep this 3, so this will be 24. So we have to keep the condition that L is, we have to answer this question. So keeping B less than this, so area is greater than this, right? So even though we are not able to answer the question that whether the length is greater than or not, so statement B is also not sufficient alone to answer this question. Now combining statements 1 and 2, right? Now statement 1 says that L into B is greater than L1 B1, right? Now statement 2 says that B has to be less than B1. Now from this inequality we can come to know that, now let us suppose that L into B, L is 5, B is 6. Now statement 2 says that B has to be less than this, so B1 to be 8 and product area of triangle F should be greater. So this is 30. So let us suppose B is equal to, sorry, L1 is equal to 3, right? So now this, so from here we can deduce that if B is less than, so LB has to be greater than L1 B1 and B has to be less than B1. So in this case we can deduce that L has to be greater than L1. That is for sure to hold this inequality, because if B is less than B1, L has to be much greater than L1 so as to keep this inequality that LB, the product should be greater than this product. So we can deduce from here that L is greater than L1, and that is a sure yes. So for this statement C, that both the statements combined give us are sufficient to answer this question. So option B, C is the right option, right? Thank you for today's lecture. Bye bye. Take care.